Hello. Today we're going to start our unit on some more informal proofs. We're using angles and triangles, utilizing the angle sum theorem and parallel lines to prove different results that the problems ask us for. Okay, this is our unit, or the beginning of our unit, on really kind of thinking through these and justifying each step that we take. So right now it says in the diagram to the right, prove that angle y plus the measure of angle z equals the measure of angle w and the measure of angle x. And it also suggests that you might want to write a label in there, so I'm going to write A next to this unwritten point. I also highlighted it. The reason why I highlighted it is because it's actually an angle in both of the triangles. Okay, so you have a smaller triangle that includes z, y, and a, and you have a larger triangle that includes w, x, and a. Now this proof is actually much easier if the line wx is parallel to the line yz, but they didn't give us those details, so we can't make an assumption that they are. So as a reminder, I'm just going to assume that xw segment is not parallel to zy, and that's important. Okay, we never want to assume anything we're not given. And so we cannot assume that xw is parallel to zy. And then basically we set it up based on the triangle sum theorem. So the measure of angle x plus the measure of angle w plus the measure of angle a has to sum to 180. The measure of angle z plus the measure of angle y plus the measure of angle a also sums to 180. Each of these is because of the triangle sum theorem. And it becomes really important that you justify each step. Later on, we'll give you a really direct format to write this stuff in. But what I notice right now is that both of these equal 180. So it's almost as if I can rewrite this without the 180 in there. So the measure of angle x plus the measure of angle w plus the measure of angle a equals the measure of angle z plus the measure of angle y plus the measure of angle a. And the reason why I'm able to do that is just plain substitution. Something you guys have been doing for a long time in your mathematics career. And then what I notice is that both include angle A. So if I were to subtract equals, which is the subtraction property, it would leave me, this is a 0, this is a 0, with a measure of angle x plus the measure of angle w equal to the measure of angle z plus the measure of angle y, which is the result that they asked for. So this is substitution, subtraction property of equality, which basically means that I can subtract equals from equals and maintain equality. Okay, you may want to pause, highlight through your own diagram to add clarification for yourself, add any little notes, details, big ideas, and then we'll move on. I mentioned that this proof becomes a lot easier if you're given that the lines are parallel. And I did want to discuss that. If these lines are parallel, then I have corresponding angles. And those corresponding angles basically would be like adding equals to equals. So I could start with one, then add the other, then make a substitution. So that's why it would be a lot quicker, conceptually. Our second problem says, given the diagram to the right, prove that the measure of angle W equals the sum of angle Y and Z. And what I notice is that angle Y is this external angle here, and Z is that angle there. So as I'm thinking through this, I do know a result about angle W. The exterior angle theorem allows me to add X and Z and equal it to W. I also notice that X and Y are vertical angles, and I know that vertical angles are equal. So kind of thinking through this initially really helps me as I go through making the proof. And so right now, the measure of angle W is equal to the measure of angle X plus the measure of angle Z, and that's because of the exterior angle theorem. And so as we prove each of these theorems, are really nice to add to like a list of tools that you can use in proof. I also noticed that the angle X and angle Y are vertical angles. And I know that based on the definition of vertical angles. I also know that the measure of vertical angles, they're equal. So the measure of angle X has to equal the measure of angle Y. And my reason is vertical angles have equal measure. And then I can go back to this first equation that I wrote and really just make the substitution in for X. And so what I see is the measure of angle W equals the measure of angle Y plus the measure of angle Z. And I'm able to state that because of the substitution property of equality. And we've done what we were asked to do. Again, pause, take down all of the theorems, make sure you understand them, remind yourself about definitions that you can use. The first four that we talked about, vertical angles, angles on a line, adjacent angles, and angles around a point, will come back regularly into our proofs, so make sure you understand each of those. Summarize, and thank you.